We now move on to the final part of this chapter. Now, question 5, I'd like you to try it by yourself. I'll show you the final answers for part A. The answer is 1 over 8. Part B, answer is 13 over 20. Part C, 7 over 40. And part D, 33 over 40. Okay, so let's go on to question 6, where we find that we have algebra involved in our probability questions. Nothing too complex, so let's take a look. A bag contains 30 stationery, so A of them are pencils, the rest are pen. When we add 5 more pens to the bag, the probability of drawing a pencil becomes 3 over 7. So find the number of pencils in the bag. Now, we're going to use the final outcome over here, probability pencil. Okay, to draw a pencil out of the total number of stationery, this is going to be the working for the probability. Currently we have A plus A is the number of pencils. Okay, we didn't add any more pencils, so number of pencils doesn't change, it is just A. What about the total number of stationery? Initially we had 30, and then now they added 5 more pen. Okay, so this is the probability of us drawing a pencil. The final statement tells us that this probability is actually 3 over 7. So this is what it must look like. And then simplify it, work it out, manipulate, we will end up with A over 35 is 3 over 7. Different ways of approaching this. You can multiply both sides by 35 to get the answer, or you can make the denominator to be the same on the right hand side, multiply by 5 in numerator denominator. Either way, you will end up with A equals to 15. So number of pencils, none. Okay, question 7. A store sells 40 fruits. X of them are apples, the rest are pears. We're going to sell 8 apples, so the final number of apples becomes X minus 8. Then, after it is sold, the probability of selecting an apple becomes 7 over 16. So find the original number of apples, meaning find the value of X. Okay, so let's form our probability of drawing apple. Right, so originally it was X, we sell 8 of them already. The total number of fruits is actually 40 minus 8, because we sold 8 apples, so the total has dropped. This is going to give us 7 over 16. Okay, so similar to the previous question, manipulate it. So we have X minus 8 over 32 is 7 over 16. You can simply multiply both sides by 32. You end up with X minus 8 equals to 14. Therefore, X must be 14 plus 8, which is 22. Original equals to 22 apples. Question 8. So Ali bought 3 packets of identical marbles, red, blue and green. These marbles, they are labeled according to the colors. Without seeing, he's going to randomly draw a marble. Then the probability of drawing a red marble is 1/4. The probability of drawing blue marble is 1 over 6. So if he randomly draws a marble, what is the probability of drawing green? For red, okay, you know what, in fact, let's change the colors. For red marble is 1/4. For blue, it's 1 over 6. What about for green? Since there are only 3 colors, then the probability of drawing green must be 1 minus 1/4 minus 1 over 6. That gives us 7 over 12. That's the probability of drawing green. No other choice. They have to add up to be 1. Now in part B, now there are 63 green marbles. Find the total number of marbles altogether. let x be total. So they're telling us that 63 out of x, 63 out of total must be 7 over 12. So our 7x must be 63 times 12. And x will be 63 12 over 7, giving us 108. Total 108. Okay, now we see how probability can also be applied in tables where we have class intervals of heights of students in the class. We're going to select students at random, find the probability that he is taller than 140 cm. Taller than 140 cm. We are talking about these two categories. And we have 7 and 2 students. So part 1, quite easily done. Probability taller than our 7 plus 2 out of a total number of 3, 6, 8, 7 and 2. So we get 9 over 9, 17, 24, 25, 26. Okay, so part 1, part 2, find the probability the student is either taller than, okay, so let's see, either taller than 140, so, oh yeah, it's still these two categories, or shorter than 120, that'll be this category. So these are the students we're interested in. Probability more than 140 cm or less than or equal to 120 cm. So, or equal to. Okay, so number of people over here, we have 12 out of 26. So simplify it, we get 6 out of 13. Okay, 10 part 1. Here we have two circles, different radius. The small circle radius x, big circle radius 3x. So we're going to randomly choose a point inside the larger circle. Find in the simplest fractional form probability that it is in a shaded area. So I'm going to just randomly choose a point. Close my eyes, choose a point. Okay, so it could be in the shaded area. Close my eyes, choose a point. It could be, oh, it is still in the shaded area. You'll see that higher chances of it being in the shaded area compared to the non-shaded area. For the simple reason, we've got more shaded area than non-shaded area. So the probability in the shaded area is going to be higher than probability in unshaded region. It's going to be more than 50%. So this is got to do with the area that is shaded. Part 1, shaded area is actually pi r square minus smaller circle pi r square. So we've got 9 x square pi minus x square pi, total 8 x square pi. So probability shaded area will be 8x squared pi divided by the total 9x squared pi. That gives us 8 over 9. Okay, so part 2 is no longer probability, it's just ratio. So give it a try. The answer is actually 3 to 4. Then we come to the last page. We've got two fair die that are being thrown. The sum of any two numbers are recorded in the white boxes in a table. So show all the possible outcomes. Now, let me orient you to this table. Die number 1, it's got 1, 2, 3, 4, 5, 6. These are the possibilities. And then for die number 2, you've also got 1, 2, 3, 4, 5, 6. In this question, we are talking about the sum. So if die number 1 shows 1, die number 2 shows 1, then the sum is actually 2. If die number 1 shows 2, die number 2 still shows a 1, then we've got 3. Basically, we're just adding up all the numbers. So 2, 3, 4, you see the pattern 6, 7, and then you move on. Now I'm gonna consider 1 and 2, so there'll be total 3. Next one, 2 and 2, total 4. You get the idea. You're gonna complete the whole table. 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, and 12. So the largest sum is actually 12, the smallest sum is actually 2. Now in B part 1, find the probability that the two numbers are the same. Okay, we're not talking about the sum of these of the two numbers shown. We just want probabilities that the numbers are the same. How many possible outcomes are there when we throw 2 dice? This table for here shows us that, well, the first die could be a 1, second die could be a 1. So we've got 1 outcome, we've got 2, 3, 4. In fact, the total number of possible outcomes shown over here, 6 times 6, 36 possible outcomes. For us to want the case 2 numbers are the same, we are looking at 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. So this probability both same. We've got 6 out of 36 possible outcomes. This is actually 1 over 6. So when you play Monopoly, right, you roll 2 dice. If the 2 numbers are the same, you can roll again. So what are the chances of rolling, of having your turn, and then the both numbers are the same, and then you get to go again? And the probability is actually 1 out of 6, not too low. Part 2, probability sum even. Okay, so it's going to get quite messy in my table. The sum is an even number, so 1, 2, 3, 4, 5, 6, 7, 8, 9. You probably see the pattern already. It will actually be exactly half, because half the time you're going to get even. So probably this will be 18 out of 36, which is half. Next one, probability sum is a multiple of 3. Let me change color. I'm gonna use a blue highlighter. Multiple of 3, 6, another 3, 6, 6, 9. Do you see a pattern already? Okay, so there are actually 6 times 2, which is 12. That gives us a fraction of 1 over 3. And we move on to the last question. So this is the information of age of participants attending a conference. We've got male and female. Out of the male and female, we've got people of different ages. Less than 30 years, very young people. 18 females, 12 males. More than or equal to 30 years old, got 14 females, 20 males. Okay, so now we understand what's happening over here. One participant is selected at random. Find the probability that this person is a female less than 30-year-old. Over here. So the probability, female less than 30-year-old, 18 out of the total number of people. We've got 18 plus 12 plus 14 plus 20. So that gives us 18 out of a total of 36 plus 30, 66. Okay, and then, 64. 18 out of 64, we get 9 over 32. Probability, male. So male will be our 12 and 20. Total 64 people. So that's half. Just nice. Probability 30-year-old and above. More than or equal to 30-year-old. So regardless male or female, as long as more than 30 years old, we are looking at this group. So 14 plus 20 out of 64. So 34 out of 64, 17 over 32. So that's all.